Welcome to another video from Learn Tech Easy on the subject Engineering Graphics. In this video, we are discussing the projections of a pentagonal pyramid lying on the ground with its triangular face and axis parallel to VP. Let us see a problem. Draw the projections of a pentagonal pyramid of base edge 35 mm and axis 65 mm long, lying on the ground with one of its triangular faces. Axis of the pyramid is parallel to VP. In this case, since the pyramid is lying on the ground with its triangular face, the axis is inclined to HP. Further, the axis is parallel to VP also. Whenever the axis of a solid is inclined to one plane, we will draw the answer in two stages. The first stage of projections will be drawn by assuming the axis as perpendicular to HP. When the axis of a solid is perpendicular to HP, its base shape will be seen in the plan. For this pentagonal pyramid, the base, that is the pentagon, should be drawn in the plan. Pyramid is lying on the ground with a triangular face, so one of the base edges, which is a part of this triangular face, is perpendicular to VP. After drawing XY line, draw a pentagon of 35 mm side below the XY line as the plan of the pyramid. While drawing the pentagon, one edge should be drawn perpendicular to the XY line. Below the XY line, draw a line perpendicular to it. Mark one side 35 mm on this line. Draw 72-degree lines on both the ends, and mark the side on these lines also. Then from those endpoints, cut arc with side of the pentagon as radius. Join the intersection points of arcs. Thus the pentagon is constructed. All the slant edges are visible, connecting the base corner and apex point. Find out the center of the pentagon by drawing two lines. From the midpoint of one side, and its opposite corner. From the midpoint of another side, and its opposite corner. Intersection point of these two lines is the apex point or vertex point. Join all the base corners to the apex point. Name the base corners as 1, 2, 3, 4, and 5, and the apex point is O. To draw the elevation, project all the base corners up to the XY line. Project the apex point O of the plan above the XY line. Mark the apex point of elevation O' on the axis 65 mm above the XY line. Join all the base points to the apex point O'. Mark the corresponding points of elevation as 1', 2', 3', 4', and 5'. These are the projections of the pentagonal pyramid with the condition axis perpendicular to HP and parallel to VP. But the question says that the pyramid is lying on the ground with its triangular face. In the elevation, the inclined line at the left-hand side has only 2 points on it, 4' and O'. That means it is an edge, the slant edge. Whereas the inclined line on the right-hand side has 3 points, 1', 2', and O'. That means it is a triangular face. So, we have to tilt the object until this line, the triangular face, touches the ground. Measure 1', O', and mark it on the XY line. Measure the base length. Cut an arc from the end. Measure the distance of 4', O'. Cut arc from the other end. Intersection point of these arcs is the point 4' of second stage elevation. Join these points to reconstruct the second stage elevation. Name the points on it. Measure and mark the other 2 points, 3- and 5-. Draw 3-0- line as a dark one. 5-0- is invisible, but overlaps with the line 3-0-. Draw the axis line also, by transferring its distance from the first stage elevation. For the final plan, project all these points below the XY line. Projects all the points from the first stage plan also. Mark the corresponding points of intersection. All the base edges in the final plan are visible. Slant edges for O is visible. 3O is visible. 5O is visible. Slant edge 2O is invisible. Slant edge 1O also is invisible. By this, we have completed the projections of a pentagonal pyramid, lying on the ground with a triangular face, and axis parallel to VP.